Say hi.
Hi, Maya and Ariella. And Sasha. Sorry.
Okay, Simon, just put your name on and give it to me. Okay, we got 2 ways that we are going to learn how to prove triangles congruent.
Side equal side and side side side.
Okay, these are shortcuts. So in the last lesson, the one that I said I'm not going to give you a proof on the quiz, right? You had to prove all 3 pairs of sides and all 3 pairs of angles. You had to have 6 things you had to prove congruent. These, what we're going to do today, and then next week, we're going to learn shortcuts. So this first one, and you don't need to really remember that it's a postulate, just we call this side, side, side congruence. We'll abbreviate with 3 S's, okay? So that means if all the sides of one triangle are congruent to the sides of a second triangle, then the triangles are congruent. So if we don't know any angle measures, all 3 sides. So if I had 3 segments of a particular size, and I had another 3 segments of same sizes over here, when we put them together, no matter how we try, they'll always end up being identical triangles. Okay, so it's kind of nice. We just need to know the 3 sides. Now we have to do a congruent statement. So we have to be really careful about the order because I didn't give you any angles. So let's just start with the triangle on the left. We can name it anyway. So let's do triangle GHI. Now, because I don't have any angles, we could probably make a good guess by the way it looks, but we can't always rely on the way it looks. So I'm going to rely on the order of the letters. So first it goes from G to H. So notice G to H goes through the side with 2 markings first, right? So
J, K,
yeah, so I'm So let's take a look. So first I go through the side with 2 markings, H, I, then I go through the side with 1 marking. And then finally I would end up going back to the last vertex. So if I'm reading this triangle, it would go G, H, I, and then back to the original if I were to kind of trace over that triangle. Does that make sense? So I need to make sure I go through the same markings on the other one. So if I go through 2 and then 1 marking, I have to start with J, K.
The one on like the test was kind of confusing.
L. Well, it's the same thing. It's the same idea. Okay, the one on the quiz happened to have parallel lines, so I was hoping maybe you found alternate interior angles to work with. But if not,
There's a proof.
no, it wasn't a proof. It was just writing the congruent statement. Like triangle, blah, 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 congruent statement. Okay, we have another postulate. This one is side angle side. We'll abbreviate it with SAS, okay? This one, well, how many sides do we need? 2. So, well, side angle side. This is important, the order. So if we have 2 sides, and we call this the included angle of one triangle, are congruent to 2 sides and the included angle of a second triangle, then the triangles are congruent. Now, the included angle is where the congruent sides meet. Okay, so where do the 2 congruent sides meet in the first triangle, the one on the left? They meet at H. Do you see how that's included? It's where the 2 congruent markings meet. And over here, the 2 congruent sides meet at the letter K. And we can see they're both labeled 95. So we have side, angle, side. Okay, the angle has to be here. It can't be at one of the other. That would not ensure congruent triangles. Okay, so we'll do the same thing. Triangle GHI. And I believe it's probably the same order, isn't it? G matches with J, K matches with H, L matches with I.
You could do it in like any order. You could also do the IHJ, right?
Yeah. If I did IHG, what would that match with the other one?
LKJ.
Wait, which one did we say? Oh, L. Yeah, so just keep in mind, like on the last quiz, if I ask you to write a congruent statement, your answer might look different than someone else's, but they could both be correct. Okay, let's take a look at these diagrams. We're just doing two. That was it. Side, and side angle side. We want to determine which postulate, side, or side angle side, can be used to prove that the triangles are congruent, if possible. So some of them might not be possible. Okay, A. Side. All three sides are there. Okay.
Side angle side.
Okay, let's look at B. Notice there are no sides marked in this picture. What are labeled here? Just the angles. This is an angle. Is that one of the postulates? No. So this one is, we'll say not congruent or not possible to prove congruent. Okay?
Isn't like angle on this side?
Yeah, that we'll do next week. That's why I said we're just doing these two. Okay.
Side.
This one we have a side and an angle. Okay. They share a side. Reflexive property means they share this side. So if I cover up one of the triangles, that angle is included. If I cover up this one, this angle is included here. So this is side angle side. Okay. Last one, we have these sides are congruent, these sides, and they share a side. Side. So what we're going to do is we're going to use previous concepts, reflexive property. We can also use vertical angles. We can use a variety of other things that we've had in the past. Okay. Now, what's nice about these proofs, I promise, these actually get easier. There's only two ways that we can prove these two triangles congruent. We can either use side angle side or side. It all depends on what information we're given. Okay, so let's write down. These are shorter than the ones we did in the last lesson. Okay? Because I'm going to label, okay, so GH congruent to KJ. So I'm going to label that.
And these ones are going to be on their tests, like on the, so not the ones from last.
Yeah. Okay. This right here, these were two segments, which ended up being two sides of these two triangles. So I'm just going to put a little S next to it so I remember, oh, I already have one pair of sides. I also have HL congruent to JL. So I'm going to put two markings here. That's another pair of sides. Okay, so far I have two pairs of sides. I'm also given L is the midpoint of.
So then GL.
Oh, Aaron.
Send him.
Spoil it. Okay. So I either need another pair of sides congruent or another pair of angles congruent. So Aaron threw out,
You should say
I guess, of side. But why?
Because
Okay.
the midpoint.
Okay, midpoint theorem is going to tell us if L is the midpoint of GK, GL and LK, are congruent. So that's my third pair of sides. I have side, side, side. So this was midpoint theorem. So step 3, I'm done. Triangle GHL is congruent to triangle KJL. Now, my reason is side, side, side.
I mean, I really wanted to learn, but Aaron got
Oh, okay, Aaron, don't ruin the next one. Okay. So, see what I mean? There's only 3 things I need to get congruent. Okay, either 3 pairs of sides or 2 sides and an included angle. That's what makes these proofs shorter and more like direct. Okay, what do we have here? You want to try this one on your own? Okay, let's start. Well, let me at least get you guys started with the given. RQ, it's already labeled here, is congruent to RS. So that gives us a pair of sides. Now, you don't have to put that S in there. I'm literally just doing that for you guys so you can kind of see as we're going. And that's it. I only gave you 1 pair of sides. But we do have, what does this mean? Parallel. So we can see these lines are parallel. Now, we don't know that RS and QT are parallel. Did you want to try it yourself?
Oh,
Do you want to volunteer?
Oh, wait, we're trying it out. Okay.
Well, Jaden asked.
I changed my mind.
Oh,
Oh, Jaden.
Jaden.
All right.
Okay, these are the lines that are parallel, which makes RT a transversal. So we have a pair of alternate interior angles congruent. Can you do an
T and R.
You know,
R and T. Half of T and
half of T and half of R? Kind of. Okay, these are the lines that are parallel. So this is, so it's got to be
So it's
here.
and then
it's
TR is then you do TR equals TR reflexive and sine.
Okay, now you're spoiling Simon. Hold on, let's slow down.
I get to learn now.
My bad.
Okay.
My bad.
Now,
My job.
do we understand why it's those 2 angles? Can we see the parallel lines?
Yeah.
Okay. Now, I can't just say angle R congruent to angle T because I have more than 1 angle. So we have to do QRT. So angle QRT congruent to angle STR. Now, you could do this in reverse order, but we have to make sure R is the middle letter here, T is the middle letter here. Again, what was the reason? What kind of angles did we say they were? Alternate interior angles. So this is alternate interior angles theorem. Okay, that gave me a pair of angles. So I'm going to put a little A next to it. Again, you don't need to do that. I'm just, looks like it's going to be a side angle side. Okay, what's our third side?
It's RT and TR.
RT and TR. We can actually even say just RT is congruent to itself. That is reflexive property.
When TR also.
You could also do TR, that's fine. But we have to say it. So side angle side means I need 3 congruent parts. It seems kind of silly, like, well, of course it's congruent to itself. But remember when I said that we were going to have to use this later when we get to proofs? This is when we use it, when they share a side. Is this side angle side? Yep, the 2 congruent sides meet where the included angles. So we have triangle QRT congruent to triangle STR, side angle side.
Why did we do the QRT? Why didn't we just do T and R again?
Well, if I said R, am I referring to this angle or this angle? So I have to specify, so that's why we need 3 letters. 2 more. I know, this is a proof heavy middle of the chapter here. But again, we only have 2 options right now to prove the triangle's congruent. Okay, so this one we have X is the midpoint of BD. And we have X is the midpoint of AC. Okay. So I have no congruent sides, but notice that what we are given is midpoint. That means we're going to use midpoint theorem twice. Okay. Now, it's important also to note what triangles are we making congruent. DXC. So I'm going to, if you have a highlighter or something, I'm going to just highlight that. Okay. We want to make that triangle. What's up? Yeah, go ahead. Okay, so I'm just going to highlight so I can see clearly. I want to get DXC congruent to BXA. All right, any ideas? Where do we go? Okay.
Like AX congruent to X.
Perfect. AX congruent to XC. You can also use the same reason to say dx congruent to xb. And remember, it doesn't matter the order of the letters for seconds. Aaron.
X is a point.
X is a point.
Wait.
That's why it says X is the midpoint. It literally says.
Wait. I did.
You knew that. Okay.
Okay. So I'm lost now. So.
Okay, so far, we're trying to get, I highlighted the green and the red one. Okay.
Oh, and then can you do?
So I have,
Can you do?
these are
vertical
two
angle?
sides.
I was gonna say do vertical angle. It doesn't work. Angle D or.
Okay.
I just gave you an
Angles.
idea.
So I don't have enough information to say this side and this side are congruent, but I can use, who said the vertical angles? Oh, both, okay.
I said that.
Use, oh my goodness, I'll just give you all credit. Vertical angles. So now I cannot say angle X congruent to angle X. I have to use 3 letters. DXC is good. And AXB.
Why can't we use just one of them?
Same reason as the last one. If I say angle X, what angle am I referring to? This one, this one, this one, this one. There's 4 different angles there. So I have to really specify. Okay, that was a pair of angles. Now we have everything congruent. So here we have side, angle, side, side, angle, side. Everything matches. So triangle, DXC congruent. Triangle, BXA. Reason, side, angle, side.
It doesn't have to be like in order.
No, so the statements can be in different order. Did you finish the last one?
I can't go with it.
You want to try it?
Yeah, should we try this on?
Yeah, let's try this one on our own. Simon, you want to go grab it?
Yeah.
Can you up?
Oh, sure.
I'll go with 7. No, it's alright.
It's okay, Miss. It's in my
I'm just
drawer.
gonna get lost.
4.4 worksheet. You can-
those like colorful bits.
No, this one is in my file cabinet at the bottom. And you can ask Miss Malikin if she's there next to me. Are we good? Sure, why not? This one is almost exactly the same as this one, where we had the parallel lines, but this has one extra step. Notice I'm not proving the triangle's congruent.
Are you not?
Well, I am, but this I'm gonna have an extra step. So
I don't. Also, whenever you're proving a triangle, you end with like a side angle, whatever that. But whenever
Yes.
you're proving like a line,
Yeah. Oh, hey guys! Oh my gosh, long time ago. Oh my gosh, what year did you guys graduate?
14.
Holy,
Can you guys tell me how many years ago 2014 was? This is math class.
were you guys alive?
Yeah.
I know, I'm just joking.
I was joking too.
What year were you guys born? 2010? 2010. Wow. Okay. AB congruent to CD. AB congruent to CD. Okay, that's a pair of sides. Okay. And they're parallel. So I had mentioned this is similar to what the one on the previous page. Okay. So I want to get the triangles to be congruent first, and then I can, once the triangles are congruent, all of their corresponding parts are congruent. Okay. Did we do alternate interior angles? Okay, you should have. Now be careful, which ones are we choosing this time? It's got to be here and here. Because these, remember, it's got to be between the parallel lines. You cannot do them on this side. Okay? Because then it's not next to the parallel lines. Do you see that?
Wait, but those lines are
That's what we did.
parallel. Wait, is that what?
Okay, these lines are parallel. So that means these are the alternate interiors, not the other ones.
A, B, D, C, D, B.
Yeah, let's write that out. So
Oh, wait, that is
angle
right.
ABD congruent to angle BDC.
It's not ABB and
I got the
CDB, ABB and
CDB, CDB is the same thing as BDC.
What about ABB?
What about CBD?
No,
No, but that's
hold on. If you say CBD, CBD would be this angle. So we have to just make sure the middle letter is the vertex. So for this angle here, I could do ABD or DBA. And then this angle, I can do BDC or CDB. But you have to use the three letters. Okay, that gave us a pair of angles. What is the next step? And actually, steps 2 and 3 can be switched around. Did you notice they share a side like the previous page? Okay. So BD congruent to BD. That's our reflexive property. You can abbreviate reflexive REF. And that gave us a pair of sides. Now I want to prove AD is congruent to BC. But I need to say this triangle and this triangle are congruent. Because once we know the triangles are congruent, then any of the other parts that are not labeled are automatically going to be congruent. Does that make sense? Okay, now we have to say the triangle. So triangle, we could do ABD is congruent to triangle. Now we have to be careful. This is something I will check for. The order matters for the triangles, okay? I can say the first triangle any way I want, but then the second triangle has to match. So if I start with A here, I have to start with C.
Wait, how come the second step it doesn't have? Like, does it have to do with the second?
CBB.
Okay, ABD, ABD, CDB.
Not CBB?
No. Why?
Because you're talking about the angle on that side.
Okay, remember I said the order matters. So AB has to be congruent to CD. The first two letters here have to match. So if I went CB here, does CB correspond to AB? No. So the segment, the order of the segments also has to match. Does that make sense? Okay, now what is the reason here? Side, 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 or side, angle, side. We only have two choices. Side, angle, side. And then now automatically, these two sides also have to be congruent. And my reason is corresponding parts of congruent triangles are congruent. Okay? Because corresponding parts, so these are matching parts of congruent triangles. Congruent triangles are congruent. It's three C's with a P and a T separating.